We have a very exciting and interesting workshop today. And this workshop, as you can see on the slide, it is going to be presented by two of my colleagues from MathWorks. I'll read some bios for each of them in a few minutes. But before doing that, just to point out, as a part of today's workshop, we invite and encourage you to ask questions. So if any questions during the workshop, we would like you to put them in the Q&A section in the webinar interface. And also in terms of the content that's shown today, we're going to have resources that are shared with you, both in some cases during the workshop, but mostly after the workshop. So with that in mind, I'm going to introduce our presenters and then they will start their workshop. So I am once again delighted to present both information about Grace Woolson as well as Wynter Duncanson. So I'm going to highlight their bios in the order that you see them listed on the slide. So Grace Woolson graduated from Hamilton College with a degree in computer science and a double minor in music and theater, then joined MathWorks shortly after 2021. Currently, Grace is a student programs data science engineer at MathWorks, providing technical resources to students who participate in competitions and creating materials to help curious students learn data science workflows. In college, Grace conducted research in the area of genetic programming, a subset of AI focused on program generation, and served as a computer science teaching assistant for 3.5 years. Grace is passionate about equity in education, and she believes technology can be a great tool for advancing these areas. Welcome, Grace. Next, we have Wynter. Wynter Duncanson is an accomplished professional with a robust background in STEM education, policy advocacy, and mentorship. With a focus on leveraging data to drive meaningful change, Wynter has played pivotal roles in promoting diversity, equity, and inclusion (DEI) initiatives within educational institutions. Currently serving as a STEM outreach engineer at MathWorks, Wynter develops and distributes STEM resources to historically marginalized student groups, ensuring equitable access to education, while also providing essential training to educators and fostering partnerships with outreach organizations. With a bachelor's in bioengineering from the University of Pennsylvania and a PhD in biomedical engineering from Boston University, the College of Engineering, my alma mater too, Wynter brings a wealth of expertise to the fields of education, policy, and diversity initiatives. Welcome, Wynter. And Grace and Wynter's workshop is entitled MATLAB for the WiDS Datathon, Predicting Timely Diagnosis of Metastatic Breast Cancer. Once again, in terms of questions, they will take questions actually in the middle of their presentation, but also at the end. And once again, let's have a warm welcome for Grace and Wynter, and looking forward to your workshop. Thank you both.
Thank you so much, Lou. Hello, everybody. Thank you for joining us today. Thank you to WiDS for having us, and thank you, Lou Bear, for the wonderful introduction. As the title suggests, today we are going to go step by step on a solution for the ongoing WiDS Datathon. If you happen to have the dataset downloaded already and you have MATLAB installed, we welcome you to follow along, but by no means do we expect that you've done that already. So we encourage you to follow along with what's going on screen, ask questions as you have them, and during and after today's workshop, we'll send out a link that has the code we're showing today, instructions and annotations on what the code means, and how you can request a complimentary MATLAB license for the competition. If you aren't familiar with this year's Datathon challenge, or I guess the current one, the goal is to create a machine learning model or any kind of algorithm really that when given a tabular data set of patient and geographic data, predict whether or not that patient with breast cancer will be diagnosed within 90 days of their first screening. So this solution is meant to kind of be a starting solution. We're not going to do everything perfectly. We're not going to do anything too complicated, but we just want to get your minds in the right headspace and help you get a running start on this challenge. As Lou said, please ask questions. If you put them in the Q&A as you think of them, we will tackle some in the middle and tackle some towards the end. So without further ado, Wynter, would you like to get us started?
Thanks. Well, right now I have our MATLAB environment open, and I want to kind of orient you to what you're seeing so that you're comfortable with where we are. So here at the top, we have
Wynter?
our, oh yeah,
I'm still seeing PowerPoint.
you're still seeing PowerPoint. Give me a second. Thank you.
It's always bound to happen.
There we go. We see MATLAB?
We see MATLAB. Thank
Awesome.
you.
All right, so here we are in our MATLAB environment. And right here at the top, we have our MATLAB tool strip. And so this really just organizes MATLAB into its various functionalities with different tabs that we'll refer to throughout this presentation. But then we have our command window here. And in our command window, we can type in commands like hello. And we press enter to execute on those commands and get hello world. We can also do some fancy dancy math and also type in, press enter to execute those commands. And so then as we execute, what you'll see is that here in our workspace, we have variables that are created. And so we'll refer to our workspace often here. And then moving up to this top area, we have our file folder directory. And this is the file that we're going to work with, this workshop code 1.mlx. And so what we have here is in MATLAB what we call a live script. And a live script is a combination of code as well as text. So I'm going to actually minimize the code window here by doing this. And here is the file folder, the MLX file that we're going to work with.
They're very creative names, obviously, workshop code.
Yeah, you know, well, we do what we need to do. So the first thing that is going to be of primary importance is we want to make sure that we are in the right folder directory. And so with our initial commands, we're going to set up the file folder directory. We're going to access this training.csv file that's downloaded from Kaggle. And then we're going to read in our data set. And what you'll see at the top is that we can run the section so that we can walk through in a step-by-step way. And so we're going to import the data in this first section. And so I'll press this to import the data, and the data will be imported. I'll scroll down so that you can see that. And what we'll see very shortly is, excuse me, a table of our data. And so in this table, we have approximately 13,000 entries by 83. And so that 83 represents the different column variables that we have access to. So we have patient data, and we can scroll along and see where they're from, their gender, BMI, and continue to scroll down. And 80 is a lot of data.
This is a lot of information.
Oh, slightly overwhelming, but what we're going to do is make sure that we can break this data down into a way that we can easily understand it and kind of get high-level information about the data so that we don't have to scroll through approximately 13,000 pieces of data. So one of the ways that we can easily do this is by getting summary information. And so this summary information gives us summary information of each of the columns. And so as you may remember, in our first column, we had patient ID. And so here we see numeric values, but then for some of the other columns, we also see cell array of character vectors. So hold on to that for a little bit later. And so I continue to scroll down, and then I see this num missing. And so this is indicating that we have missing numbers for a few situations. A little concerning, but I think we can figure this out. Oh, there's cell array of character vectors. Again, a lot of those. And then if we look at the min and maxes of the various columns, what we see is 635 is way different than 0.91. And so we see a spread across the minimum to maximum values. So overall, those are some of the things that I've seen in the data. So here are some of those things that I noticed, just to summarize. One, we noticed that there are a lot of rows or variables that say cell array of character vectors. So when we feed these cell array of character vectors into a machine learning algorithm, it doesn't really understand it. So we want to make sure that we fix that. Then we see a high level of num missing values. We want to clear out that missing data. Grace, you wanted to add something?
Yes, sorry. So that one, it should be a lot of columns. The variables are the columns. That was a typo on my part, and I apologize.
Oh, my bad. So then also we have numeric variables can have various dramatically different mins and maxes. So let's begin with trying to clean out this data to make it more usable for us. So in this first section, we are going to convert our text data to categorical. And in this very first part, what we see is we have double and cell. And so this really gives us a better sense of what is the data that we have available. Again, lots of doubles and cells. And ultimately, we want to have categorical and cell and doubles. So we will finish this up, and there won't be any output here in the live script. But if you look towards the workspace, you'll see that the variables populate the workspace. So let's continue along and figure out how to handle that missing data. So with this missing data, what we're going to do is we're going to look for the number of columns that are missing over half of the data set, because this won't necessarily be useful information to us. So I'm going to run that section there.
Yeah, there's a point where like some missing data, there's algorithms to fill it in, or maybe you can just learn around it, but over half could prove troublesome.
Bit of a problem, but it doesn't look like we have that many columns or that many variables that are missing that much data. We have BMI, metastatic first novel treatment, and treatment type. So not too bad, but still, let's remove those just to keep it clean. So then, all right, now, we still have approximately 13,000 by 80 for our table. Still a lot of data to work with, and let's figure out a way to continue to clean that data. One of my favorite parts of MATLAB is that we have these live tasks, and our live tasks are found here in our MATLAB tool strip. And so here's one of the live tasks that we use. It's the clean missing data live task. And I just start typing in CLEA, and it autofills. But we've already used this task, but I wanted to show you where it was so you can find it later. All right, so we are going to clean this data, and our minimum for removing data will be two missing. And in the previous section, we looked at missing across columns, and this time we're looking at missing across rows. And so this is kind of where the distinction is here. All right. And
so Wynter, if I may,
yeah.
just to make sure that I understand. So
Yeah.
we're going to go row by row.
Mm-hmm.
And then for each of these rows, we have 80 columns.
Yes.
So if 2 or more of those 80 columns are missing values, then we're going to remove the whole row.
Yes.
Okay.
Yeah.
Awesome. I think that's just because you ran it twice, so it already
Thank
took BMI out.
Thank you very much. All right. So we are cleaning that data. And then we are going to further divide that data. This is what I call my little divide and conquer strategy. Okay. So here we plot the missing data versus the clean data. And so our X points are those that are removed, and the blue lines are the clean data. So though we're removing so many data points, we really have enough data to work with to be able to make reasonable conclusions and assumptions. And if we want, we can choose other variables to display by clicking on any of the approximately 80 columns. All right. Here's my divide and conquer strategy. So remember, the goal of this is to figure out who are the patients that were diagnosed within the 90-day time frame versus outside of that 90-day time frame. And so we want to split up that data set into two. And so we'll call those true and false. And the true will be those that have been diagnosed within the appropriate time frame of 90 days, and false those outside of that. So then what we see is that we generate two different tables. And one of the things that we notice is that there are approximately 8,000 in the true data set and about 5,000 in the false data set. So more of the population was diagnosed within the appropriate 90-day time frame. So then I can go through each of these columns and see, well, all right, is there anything that I can learn from scrolling along here? Is there a trend in the density? I can actually organize these by sorting them from largest to smallest or smallest to largest. And all right, so I'm not really seeing much information. Well, I see some information, but I can't really make any conclusions. Let me compare this to the one below. All right, so let's scroll over the density. Don't really see much. So, and then when I choose the little drop-down menu, I also have the option of updating my code. So if I want to look at my data in a sorted version from smallest to largest or largest to smallest, I can update the code to reflect that. And I'm not going to do that right now. So right now I'm trying to compare tables to tables. Really, probably having a graphical visualization would probably be easier for us to make some reasonable conclusions for that.
Yeah, I can't say I'm learning much by looking at the tables.
Thanks, Grace. So here is where we have another live task option that can actually be helpful. And so we wanted to talk about visualizing our data set. So first, we can look at one variable at a time. And so the variable that we're choosing to look at is the health of the percentage of the population that is uninsured. And so I'm going to run this section, and I'm going to generate a histogram of the true versus the false population. And my little easy thing is true is blue, and then red is false. So here, what we see is that the true group is higher in terms of the histogram counts versus the red group that's false. And remember when I said that we have a larger population of the true group versus the false group. So we're always going to see higher values in the histogram. But then what it looks like is that the shapes are kind of similar. It seems like they're not necessarily a normal distribution. It's a little offset. And so maybe there's a bit of skewness that we're seeing here. So hold on to that for later, because that'll come into play as we continue to delve into this data set. So then we can also look at not just one variable, but two variables at a time. So again, using our live task of creating a plot, we can create a visualization that's actually a scatter plot that allows us to look at the percentage of uninsured across the population versus the state. And I'm not sure if you can see all the state names. So what I can do is I can pop this out so that we can see. Oh, hold on a second. So that we can see a bigger version of this. Let me scroll up. Oops. My bigger version is a little hidden by Zoom, alas. But what we see is that it seems like if you're from a greater percentage, an area where most of the people are uninsured, you tend to have more um, false diagnoses that are outside of that 90-day time frame. And so then this seems to happen for what is that, Georgia, then Oklahoma, about Oklahoma and Texas. Not sure I want to be in those populations. What do you think, Grace?
Yeah, I think it's interesting because we were just looking at like, okay, well, does it matter if you come from a population that has a high percentage of uninsured people? And overall, it seems like the answer might be no, but once you break it down by state, like some of the states, the reds and the blues, the trues and the falses are mixed, but in here you can see some of the states there's a pretty dramatic distinction.
All right. So, all right, we had a nice graphical visualization, and so that helped us to see a little bit more information. But I'm an engineer. I love to quantify, and so we can do a statistical analysis really to look at that level of skewness. And so, if you remember, I pointed out that when we had our histograms, they were a little offset, and so maybe skewed to the left or to the right. And so what we can do is break down those two groups into which one is screwed to the left. So if it's skewed to the left, we're going to get a 1. And then if it's skewed to the right, we will get a 0 and, -1. And then if it's right in the middle, it'll just be 0. So we can start off with that and then move from there and calculate, are there any statistical significant differences between the skewness between the different groups? And so then what it seems like is we have approximately 4 groups where this skewness is in fact significantly different. And I mean, this gives us some information, but I don't know if it really helps us to distinguish what are the defining characteristics and features that help us to distinguish, am I going to get diagnosed within 90 days or outside of that 90 days? So I give it to you, Grace.
Yeah, so we're going to switch over to my screen to start talking about more the machine learning part, now that we've explored our data. But while we do that, I think we have some time for questions. Yeah. Should we read those right from chat, or Louver, do you want to read those to us while I set up my screen?
I can assist and read them from the Q&A panel if
That would be
that's
lovely.
okay. Okay, great. So we have, and I'm trying to read them in order, so here we go. Can we open MATLAB in Jupyter Notebook?
Yeah. Going to answer this with Wynter, if I may. If you want to take this question, go for it. But we do have integration with Jupyter Notebook. I can see if I can find that link. But we also have this lovely thing called MATLAB Online. If you don't want to install MATLAB, or if you're working online with folks, MATLAB Online lets you open MATLAB Online and store everything on the cloud. Yeah, so yes, and also we have some other options.
Okay, this is great. I was very tempted to answer a lot of these questions myself, but I held back. Said the presenters are going to answer. Here's our next, and I'll make certain we acknowledge it was answered. I'll do that behind the scenes. The second question is this Jupyter Notebook? Is this the Python language? I think that's what the question was trying to refer to. So
Awesome. Yeah. So this is MATLAB, in case you missed the beginning. MATLAB is its own language, its own environment. So no, this is not Jupyter.
okay. And then we have the following question. Is there something like sklearn's pipeline in MATLAB?
So we'll get a little bit more into the machine learning part in the second half of our presentation. I believe that is more what sklearns would pertain to. And then after that, if you have more specific questions about it, maybe we can answer it, but I'm hoping we'll start to answer some questions as we go along about that part.
Yeah. And then for the final item I'm seeing, it looks like maybe it's more of maybe a comment, so I'll read it. I believe that what is applied to training data set should also be applied to testing data set. We can still delete columns in testing data set, but not rows.
Right. And I'm pretty sure that Grace will actually address that in the next half of the live script. So go for it, Grace.
Yes, this is a great
Amazing.
segue, and that's all we see for questions now.
Yeah, but you believe correct. So that's a good, we'll get there. Can you guys see my screen okay? We're seeing
Yes.
MATLAB?
Yes.
Amazing. So a lot of the exploration that Wynter just did is helpful for a couple of reasons, and I'm going to focus on two. One, this is an interesting data set. It's an amazing data set that I'm so excited to be working with. So the challenge focuses on one particular aspect of the data set, and it lets you explore and find different possibilities. But at the end of the day, the Datathon has one specific goal. It's to create this algorithm. But if you want to take the time to explore other relationships, algorithms, things you find interesting about the data, not only are you enriching yourself, but they're fun discussions to be had. So Kaggle has a discussions tab, and I think it could be a fun way to start having conversations about the things you're noticing. And the other reason is for what we're going to do next, which is feature engineering. So by taking some time to explore the data and learn, okay, this column seems like it might be helpful, or this column feels like it might be redundant, or if you put these two columns together, you can get a whole new metric. So feature engineering is the process of going through the data that you have and deciding what you want to keep and combining it or performing operations on it to make new data. Now you can do that manually, which is what a lot of this exploration is helpful for. I'm going to automate it a little bit because I wanted to show off one of our cool features. It's called Gen C features or generate classification features. We'll pass it our data set, our predictor, or the output, sorry. And I'll say that I want 6 columns. That's what this 6 is. Right now we have 80 columns, which is a lot of data, but I want to start simple, and this will allow us to train some machine learning models faster. So play around with this number, but I'm going to start with 6. This takes a second to load since our data to run since our data is so long. So I actually have run this already. So we'll see that I have a T and an OG train data in the workspace, which I know it's a little small, but if you can't see it, you'll have to trust me. And so OG train data is our new 6-column, 7-column table. And T is the feature transformer. So T will allow us to perform, as we kind of talked about, this transformation on future data sets. So whether that's the testing data or the submission data, it allows us to make this reproducible. And I will use describe to see how it created our data set. So these are the columns that we have, essentially. And so it'll take existing columns and perform some math. We see this one here combines a couple rows. They all get z-score, which is just a way to standardize the data. And this handles the difference in ranges, so the minimums and maximums. It's all a little bit more standardized. Yeah, so this just helps us understand for explainability and reproducibility. Now with any machine learning algorithm, or workflow, I should say, you're going to want to split your data. So I create some training data, which will be used to teach and fit our machine learning algorithm. And then a testing set, which will allow us to see how well our model performs on new and unseen data. And I'm going to split it into 80% training and 20% testing. But again, this is a value that you can play around with, see what works for you. And now we can dive into training. So I'm just going to start by training a tree which is a simple, common kind of machine learning algorithm. Totally okay if you don't know what that is. It's just a starting point that I chose. So click in here. I'll run that while it runs. I'll explain some things. So you'll notice that I have this optimize hyperparameters equals auto. So for any of our machine learning algorithms, if you set this, it's going to run some experiments to try to optimize one or more of the hyperparameters for that kind of machine learning model. And I will see if I can. Some stuff's going to be appearing while I'm talking. I'll give us a second to look through it as well. But this is it running the different experiments. For trees, the parameter that it is trying to optimize is the min leaf size, which is the minimum number of observations per leaf in a tree. If that doesn't mean anything to you, that's fine. It's a little out of scope for what I'm explaining today. We're just kind of trying to get you a whole workflow. But the point is, you don't really have to know what that means. MATLAB has the ability to try and automate some of that thinking for you. So this is going to take a second to run, but not usually too long. And then I'm also going to talk about something that I'll start talking about while this is running. So I chose a tree. I like trees. They're a common structure. But there are a lot of different machine learning algorithms out there. And I can't remember all of them off the top of my brain, or I don't know how they're all going to work with different data off the top of my head. So we have something called a classification learner app that I will take a moment to show you once this is finished running. But essentially what that allows you to do is take your data set, upload it to this app. So it's all going to be point and click, no coding for this part. And interactively test out a bunch of different algorithms. I'll get to that in a second, but we can see here, it's doing a lot of math. It's trying out a bunch of different min leaf sizes. We've got a pretty big data set, and it'll keep going until it comes up with your best min leaf size. And again, so the link that we'll send out after will have these graphs in it. So I encourage you to take some time to explore it, play around with your own. But the essence of this is it's running experiments for you and trying to automate some of that. Great. So classification learner. We have this apps tab. So we've got the live tests, which are small interactive things, but we've got the apps because we love apps. And right here, we've got our classification learner app. And Wynter, can you see the app? Awesome. I'm going to full screen it just for simplicity. I'll do a brief tour of this. I don't want to take too long, but we'll start a new session and we have our data in our workspace, which just means we've already loaded it. And that's going to open a pop-up window, which will allow us to choose our data. I have had this open all morning, so it might, oh, there it is. Okay. And then we will choose training data. And then we'll see our different rows show up here. So we've got our 6 variables and our predictor, which is grayed out because MATLAB automatically assumes that the last variable is probably the one that we want to predict. And there's some other options, but let's just start the session. And so that's going to bring the data into the app and tell the app how we want to work with our data. It'll give us different options based on what kind of data we have. And by default, it'll create a plot for a tree, which, like I said, trees are pretty common. It's a good starting point, which lets you do some of the exploration that, we were talking about during Wynter section. Amazing. Perfect. Didn't want to open that too fast. Now, again, we'll see a bunch of options. You don't need to use all of them. You can explore some of these on your own time, but this drop-down menu here is the meat and potatoes, my favorite part of the classification learner. So there's a bunch of algorithms built into this app, and you can choose to train one of them. Let's say I want a support vector machine. So I'll click on one, it'll add it here. So now I've got a tree, I've got a support vector machine. Usually as a starting point, I will choose this all quick to train just to see what kind of algorithms are working best. And then you'll train it using this train button, and then you can export your model. Again, I'm not going to do it now because training can take a while. But when you export your model, you have the option to just export the raw model itself to use it. You can export code that recreates your model. So if you want to keep it, make it reproducible, and maybe make some tweaks to it, it's got your back. Awesome. I'm going to close this because that was just a brief detour. Check it out. I love it. Great. Once we have a model, we've got our tree, you can test it. And there's a couple ways to test the model. So first, I'm going to do something. I'm going to use validation. Validation is essentially, at a high level, the process of, let's say you have your full, we have our 1,200 rows of training data. We're going to take out a chunk of that data, retrain our model, or train our model for the first time, depending, and then see how well it performs on that chunk of data. And you might do that a couple times. Typically, you'll take out different chunks of data, and you will average how well it performs each time that you do it. And that's going to end up being your validation error or loss or accuracy, depending on how you want to do it. So this cross-val right here is going to perform cross-validation, which is what we just explained. It's going to do that 5 times. We'll have 5 folds. And then we'll take the loss, which is classification error in this case, and I'm going to subtract it by 1 because I like accuracy as a measure. You want it to be higher, so that's how I'm going to do it. And we'll see that this has an accuracy of 81-ish. And we're basically going to do that again with our testing data, which is just bigger than our validation data would usually be. Similar ways of calculating error. And we'll see it's about 80%. So pretty consistent, which is good, doing well. Amazing. Perfect. Now those are numbers. We like numbers. We were talking about, we're engineers. I'm actually a computer scientist, but we like numbers. But sometimes visualizing things helps you get a better understanding of where you could be improving. So we know that we're getting it right 80% of the time, but we don't know what that 20% of the time is. So I'm going to create a confusion chart, which is going to help us understand how often it is predicting things correctly, how often it's predicting things incorrectly, and which classes it's performing correctly and incorrectly. So if you've heard the phrase true positive, false positive, etc., I'll stick with those for now. That is essentially what this is showing. So we have our true classes and our predicted classes. So when the true class is 1, so yes, the patient was diagnosed within 90 days, typically it gets that one right. We're seeing 1,400, 1,500 true positives. That's what this is. Yes, it's getting it right. It is a positive, it predicts positive. And we see 52 false negatives, I believe. Yes. So it says that it's 0, it's a negative class, but it is actually the true class. But most of the time it gets this one right. But if we go up to if the true class is no, they were not predicted, they were not diagnosed within 90 days, it's only right about 50% of the time. And that's a problem. It shows a flaw in our algorithm. And so this could reveal, okay, maybe you need to train it longer. Maybe we probably have a bias in our algorithm and in our data, because as Wynter said, we have more true data than we do false data. And so by learning how to get all of the true correct, by guessing true often, it manages to get a pretty high accuracy. So that there's a bunch of different things at work. We got to play around with. So yes, on a very similar note, there's something called a receiving operator characteristic, commonly called the ROC curve. And this also explores true positive rates versus false positive rates, as you can see here. So this blue line represents our model in terms of how well it predicts the true class. And this dot here is our operating point, which is where our model currently is. So we've got true positive rate. The dot is pretty close to 1. I'd say above 0.9, below 1. And so this means that it predicts the positive rate 95% of the time, as we saw up here. And it predicts false positives. So it was actually negative, but it predicted that it was positive about 40% of the time. So this just echoes kind of what we're seeing up here. I just wanted to show two different ways of looking at it. And you can also plot this against, we see here it's 1, which is the true class. You can plot this for the negative class, but for a binary classification problem like this, so where we have two classes, the curves will always be mirror images of each other. So there's no reason to plot both. So an AUC, which is area under the curve, I'll write that here, is the area underneath this curve. So a perfect score would be right here. It's always right and never wrong. So the more area under the curve, the better your model performs. So between 0 and 1, and here we're seeing about 0.75 or 75%. So again, pretty good. Definitely room for improvement. Awesome. And you want to repeat that whole process a bunch of times. You'll want to make different models, try different algorithms, process your data differently. Just, treat it as a playground essentially until you're getting better area under the curve, better accuracy, numbers that you're happy with. And once you do that, it is time to create your submission. So when you download the data from Kaggle, we've got our training.csv and you've got test.csv. So we'll upload our test. And test does not have outputs for us to compare it to. We have to create the, it's the 90-day diagnosis ourselves. And we'll see that this is almost 6,000 rows. And again, we've got our 82 columns, not 83. Perfect. And we're going to pre-process it just the same way we did before, but you're absolutely right. For a competition, you can't just choose to ignore rows. So we're going to take out the columns, and I do this all programmatically, but this just does all the pre-processing we saw earlier. And then we see T has come back because we're going to, the output of our Gen C features earlier, we're going to take that and we're going to transform our test data. So when we run this, we should have 6 columns. And we'll see we've got our 6 columns with the same calculations as before. Now that our testing data is ready, you basically just need to make your predictions, which we'll use the predict function to do, which just returns a row of predictions. It'll be 1s and 0s, the rows of true and false. And then we put it in a table so that we know which patient that prediction is associated with. And this is also the required format for the Datathon. And then you can export it to a CSV. And just like that, you've got your submission and you're ready. I believe Kaggle allows you to submit twice a day. If Valerie or someone wants to correct me, let me know. But you don't have to have a perfect model to make a submission. You just have to have your first model. So I encourage you to participate. Awesome. And are you seeing PowerPoint now? Beautiful. I'll put this in presenter mode for fun. But these are the resources. Again, we can send this in the chat if we haven't already. But the QR code and link on the left is where you will request your complimentary license for MATLAB. And the code on the link on the right is a blog post that contains all the code we showed today, as well as text explaining what all of the code does. So check it out. And I'll leave this up if we want to start taking questions.
So I wanted to start by saying thank you to both Grace and Wynter for your workshop and sharing your expertise with us. And keep in mind, you pretty much have a lot of guidelines at this stage to help you with the datathon. So you have the resources that Grace and Wynter is sharing with us, and I think these are going to be helpful resources for quite a few. And you do have a few questions in the chat. So what I'll do is read the questions out loud like before, and then we'll get some answers. So here is question 1. And sorry for the Q&A panel. I did see a question in the chat as well. I'll try to bring up that question too. So there should be 3. So this first question in the Q&A panel is, so is the classification learner app in lieu of actually coding in MATLAB, or do you need to use both?
Fabulous question. It is in lieu of. You are welcome to use both. So a very common workflow is if you want to start in the classification learner app, export your code, and then make some tweaks there. But you do not have to write any code at all if you want to use the classification learner app. So I highly recommend it, especially for when you're first getting started, either as a data scientist or with a new data set.
And Grace, may I add one item? So you can
let me add.
Wynter, yes.
I'm like,
here you are,
also,
Wynter.
Also, with the live tasks that we were showing before, there's also an opportunity. So you can do the live tasks that are low to no code and then export the code, and voila, you have your code right there. So I use those all the time.
Yes, so I'm going to +1 what Wynter just said. So many of the apps that you can use from MathWorks, you can typically generate code, and it's a great starting point. That's great. And then for the second question, so is there a way to trace back the last iteration to see which features popped up the most in the top performing model?
So I know that there are ways to see which features are most important, but I don't know if there's a way to do that during training in machine learning. I don't know if Wynter or Lou, you have a better answer to that, but this is something that I would have to think about.
So there are some pathways to, as an iteration is going to get certain values based on certain metrics. And typically the pathway is it could be done programmatically. So we could do some further investigation to try to show an example. There should be an example or two, but it typically does entail writing code versus possibly using an app. So we can definitely highlight some examples. And this is the next question. I'm going to get to the question in the chat too. I'm trying to look for it. But at least in the Q&A panel, this complimentary MATLAB license, does it have any time period or expiration date?
Awesome question. So the license is intended for the datathon. So if you request it, you'll have access during this datathon and the following ones. If you don't know, there's 2 datathons this year. So you should have access to it, I believe, through the end of June. We like to give you a little extra time. I know that the competition ends on June 1st. The access seems to be for 30 days. It definitely should be more than 30 days, but if you are having problems, I'll put an email in the chat that you can reach out to. So if you get a license expiration notice before the datathons close, I will send you an email that you can reach out to.
This is helpful. And another question just appeared in the Q&A panel. So thank you. My question is, if we can use the classification learner app to run all different algorithms so it doesn't make Python super flues? That's what I'm seeing. So
I'm going to
let's
go
see.
with superfluous.
Yeah, I was wondering about that because I was like, is this what we're looking for? So what is the answer to that question? Indeed, sorry,
Indeed. Okay.
typo. Yes.
Yeah, so you can run the classification learner app to run, I don't know if it'll have every algorithm under the sun, but I know we have a lot in the classification learner app. And it is customizable, but you might have to make some small tweaks to it. Again, like if you export the code and then make some tweaks. So it should be as customizable. Like the idea is you'd be able to do this without Python.
And we have a few other questions that have come up, so let's look at those. So do we really need to use NLP in order to process or clean the breast cancer diagnosis desk description column? If so, can you explain more, please?
Wynter, I'm sorry if let me know if I'm taking too many questions. My job is to be the data science here. The data science part of it, Wynter has been amazing. So just wanted to put that out there. But technically, you don't need to do anything. You could take the data set, put it in the classification learner app and hit export, and that would be the whole thing. You could make a whole submission with like 2 lines of code, and that one of them being predict and the other one being write table. But trying out different things. So again, in our example, we just converted it from a series of letters to a category, which just makes it easier for the machine learning models to understand what those characters mean and group things together. So people from California are from California, not from CA, you know. I hope that answers your question. So again, you can do simple things, you can do nothing. Different things are going to work.
And just to add, this is under the, category of assisting with pre-processing that could be implemented. So in terms of, your data science workflow in general, what you decide to do pre-processing wise, it will impact that result. So you have a lot of
Right.
options as Grace highlighted. So that makes sense. And then we have another question. So I'm going to add in a few words to this. So what is the learning curve from Python libraries to MATLAB or vice versa?
Lou, would you like to go first? And then I can hop in as a
Okay.
computer scientist.
Will do. So I have to admit, it's going to vary. It's going to depend on a few different factors. One of the items that I think about when learning a new tool, or in this case, I'm going to say a program language, is what are we trying to do as far as the programming language? Because I think the task that you're trying to associate with the programming language are a big factor with learning about the syntax of the programming language. A big factor for any programming language is, how much time can you devote to practice? And I have to admit, I used to train people how to use MATLAB, and I would say, you know what? In as little as 5 minutes a day, you could build consistency and familiarity. So I just want to say, think about consistency and familiarity, but I have to admit, overall, the answer is it does depend. If you've had prior exposure to a programming language, I have to admit, it typically starts to seem as if, okay, you can typically pick up the other programming language, just their syntax changes. Hope that
Yeah.
high level helps out. So anyone else, feel free to jump in.
Yeah. So this might be blasphemy to say wearing a MathWorks shirt, but I'm a Python developer by training. That is my language of choice by training. And I picked up MATLAB very quick in terms of syntax. And like, it's very similar if you've done object-oriented stuff, very similar there. Our libraries work differently. So if you're specifically talking about the Python libraries, we don't have like import pandas as PD or import, we don't have any of that. So what you'll find is that the functionality is kind of built in for things that come with our toolboxes, things that come with MATLAB. So, and then we also have a community forum repository called File Exchange that works a lot like the libraries, where you can go search for what you're looking for. and you just install it and you get the files. So you don't have to do any of the importing kind of thing. It just happens. So that the syntax of that is going to be different, but I wouldn't say it's difficult by any means. Hope that helps.
Hope that helps too. I think it did, but we'll find out. And just to be knowledgeable of our time, so we've got 4 minutes left. So with that in mind, I'm going to say, let's say thank you to Grace and Wynter for the awesome workshop that they presented to us today. And with that in mind, this is going to conclude today's Wednesday WIDS Upskill workshops. We hope that you found this workshop informative and valuable. If you have any questions for Grace and Wynter, please continue to post them in the Q&A, and the WIDS workshop team will send those questions to Grace and Wynter afterwards. You can follow up if need be to help share answers and possibly pertinent resources. You can also connect with Grace and Wynter via LinkedIn. So if both of you are comfortable, we have those wonderful LinkedIn profiles we can share in the chat, and everyone can connect and we can grow the WIDS community. So on behalf of the WIDS Workshop Committee, thank you to all of the instructors and those who helped organize today's event. We are grateful for your time and efforts.